we can have to improve the mixing, so on and so forth. Okay, so both of these will be more on the application part. Okay, so whatever you have learned with Dr. Halina is more on the fundamental. For my part, will be more on the application part. Okay, so again, these are the books or reference books that I'm using, that I hope that you will also be using. Okay, so these are the three important units. So if you see here, the first one is unit operation of chemical engineering. Okay, so there's a big part in this book for fluid mechanics. So whatever Dr. Halina and I will teach you is coming from that book. So if you have the opportunity to get the book, so please do, because you'll be also using this book in the coming semesters. Okay, and then you also have the second book is by Eunice A. Siegel, Fluid Mechanics, Fundamental and Applications. Okay, so here also you have the fundamental part and also the application. And the third book is Ingredient Coplis, Transport Process and Separation Process Principle. Okay, so these are the three main reference books. So meaning to say that most of whatever I'll be teaching you will be coming from these three books. Okay, so some of it from maybe from book number 1, some of book number 2. So depending on the topic that we are learning. Okay, so I think it's always available online, or if you want to buy it, you can also buy it and get a hard copy for it. Okay, so for the course outline, okay, so we have two objectives here. Okay, so the first one is that, okay, so this objective is specific for the two topics that we will be covering for the next 7 weeks. Okay, so it's not the overall objective of the course. The overall objective, I think Dr. Halina has already mentioned to you in the first classes, right? So this is the objective, specific objective for the topics that will be covered by me. Okay, the first one is going to be to discuss the fluid moving machinery and meters for measuring fluid flow rates. Okay, so if you see here, there are two important terms here: machineries and meters. Okay, so this is basically what we talk about when we say we want to know the how to transport, how to move the fluid from one position to another position, or from one location to another location. So what kind of machine or what kind of equipment that we're going to be using. So that is our first to discuss. When we discuss, at the end we want to understand. Okay, and then the second one is that to discuss the mixing process for liquids. Right, it's really straightforward, right? One is that we want to know how the fluid can be transported and how we measure the fluid flow rate. And the second one is that to discuss the mixing process. Okay, so we'll be looking at all these topics in detail. And then at the end of this course, for my 7 weeks, right, for the part that I'm teaching, students should understand the Bernoulli equation and its application for pump design. Okay, so keyword here is Bernoulli equation. Okay, I'm telling you from now, from the first class today, Bernoulli equation is one of the most important equation that you must understand and able to apply and use. Okay, it is a very important equation when we are talking about pump design. And when we say pump design here, pump design, there are a lot of elements in your pump design. Okay, just to name a few, you want to know what is the pump work done by the pump. Okay, work done on the pump power. What is the pump power? What is the pressure? What is the height? All these things is related to your pump design. Okay, so whatever we have to talking about pump design, we also have the NPSH. Okay, whether the pump is suitable or not suitable, all the things that has to do with design, most of it will be using Bernoulli equation or its derivative. Okay, we can come up with a new equation by actually using this Bernoulli equation. So, but before you can actually use the complicated or the derived version or the new equation derived from the Bernoulli equation, you must first understand each and every term in the Bernoulli equation. Okay, so I think that's why, based on my conversation with Dr. Halina, she has actually shown you how to actually derive the Bernoulli equation. By right, the only thing you should know is that how to use it and how to apply it. But it's always very important if you can actually know how it is derived. So it can improve your understanding. Okay. The second one is, at the end of our 7 weeks together, you should be able to calculate flow rate from the meter readings. So here you'll be introduced to a few types of meters or equipments that can read the flow rate. Okay, you can have venturi meter, you can have orifice meter, you can have rotameter, you can have pitot tube. All these things, the main function is that to measure the flow of the fluid. And then the third one, of course, if we have discussed the mixing process for liquid, so after we have discussed, by right, you should understand and know what is the mixing process for liquids. Okay, so basically, at the end of 7 weeks, if you have understood and you are able to answer to me all these three questions or all these three statements, you can solve questions, you can explain, you can do all that is related to these three questions, meaning to say that you have actually achieved whatever we set to achieve in today's class. Okay, so please make sure, even though this is just an introduction, okay, even though this is just a simple things for you, but it is very important for you to know from the beginning before we go into the details on what is expected from you. Okay, so if let's say after 5 or 6 weeks, after 7 weeks, when I give you a question, when I ask you to design a pump, you could not design the pump, so meaning to say that you did not achieve this. Okay, if you did not achieve this, then maybe this one is maybe I can say this is like 40% of whatever will be covered in the 7 weeks that we have. So meaning to say that you have not understood 40% of whatever we have been discussing, whatever I have been talking, whatever explanation I've been giving, right? So meaning to say that you did not achieve whatever objective that we set. Okay, so please make sure that you take this, you pay attention to this one. Okay, so the next thing is that I hope this one is already being told by Dr. Halina, but this is just a revision for everybody. Okay, so our coursework, our IEK 108, the assessment is divided between coursework and final exam. Okay, under normal circumstances. Okay, this semester is still considered as a semester under the COVID pandemic. Okay, so under normal circumstances, if there was, let's say, no COVID, okay, this one I'm talking about in 2019, okay, few years ago. So for your seniors, we had 60% coursework and 40% final exam. Okay, so I hope Dr. Helena has mentioned this one before. This is just to refresh your memory. So 30% test, 30% assignment. And usually, if you have final exam, you will have 4 questions, answer all questions. But this semester, we have converted this 40% into your test and assignment. Okay, so that is general. So you have 30 plus 30 plus 20 plus 20, you get 100%. Okay, so for my part only. Okay, so you have done your assessment or you are doing the assessment for Dr. Halina. So starting this week, we'll start the time when you do assessment from me. Okay, so from the 30% of the test just now, okay, this one is divided for Dr. Halina and myself. This one also divided with Dr. Halina and myself. So 15% for Dr. Halina, 15% for me. Same goes for assignment. Okay, so that's why we have test 15% and assignment 15%. Okay, so for test, you'll have 2 tests, test 3 and test 4. assignment, you'll have assignment 3 and assignment 4. Meaning to say that each of the assessment, the test 3 will be 7.5%, test 4 will be 7.5%, assignment 3 will be 7.5%, and assignment 4 will be 7.5%. Okay, so it might look a lot to you, right? So you will, in total, you have 4 assessment degree, right? But the reason why we have more assessment is that number one, okay, number one, we want to make sure that you actually understand. Okay, so all this assessment that we give you is basically to test you, okay, to find out whether you understand or not, whether you are able to follow or not. Okay, and this is also from for your improvement as well, because if let's say you did not do well in test 4 or test 3, this should indicate to you that you did not understood whatever have been discussed in the class. So you will have to work harder on it, or you can always come and see me and we can discuss whichever part is difficult for you. Okay, so the same goes for test 4 and assignment 3, assignment 4. Okay, and the second reason why we have multiple tests and multiple assignment is because we want to make sure that you'll be able to get good grades at the end of the course. For example, now if let's say there was only one test and one assignment, if you did not do well in your test, let's say you just, you were sick on that day, or you were, having some problem, family issues, or whatever it is, you were unable to perform in your test. So you, let's say you get 0 here. So 0 meaning to say that you have lost 15%. You have, if you have 100% in total, you minus with 15% if you did not do well in your test. Sorry, so not let's say 30%, right? 30%, because my coursework is only 30%, right? So if you did not do well in this 15%, if let's say we only have one test, so you only had 15% to go, which is assignment. And if let's say you did not do well in your assignment as well, let's say you did poorly, so you only got 5 marks, so you minus 5, so in total you only have 5 marks. So 5 out of 30 is a very, very low mark. Okay, so instead of that, so if let's say we have multiple tests and multiple assignment, you have more chance. If let's say you did not do in one test, you did not do well in one test, you had other opportunities to do better in the test 3, test 4, assignment 3, assignment 4. Okay, same thing goes for your assignment. If you did not do well in assignment 3, you still have opportunity to score in assignment test 3, test 4, and assignment 4. Okay, so I will try um, to distance or to put the assignment and test as far apart as possible, because we only have 7 weeks, so there might be some overlap here and there. But again, I will always tell you when is the test dates and what are the topics, that so that you can always focus. Okay, so that is for the coursework part. And then for the final assessment, okay, Dr. Halina will be doing the test, and for my part, I'll be having an assignment, a final assignment. So in total, my part will be having around 50% of the total 100%. Okay, so the final assessment, I think we'll be having this during your, I think it's on week 16, if I'm not mistaken. This one is week 8. So 15 is the final week, yeah, week 16. Okay, so once we have finalized the date and the time, I will put in the WhatsApp group. So I will tell you ahead of time, right, when is your assessment. By right, but we already have a week. I think it's going to be week number 16, but we haven't finalized the date yet, right? Because we have to, I have to discuss with Dr. Halina and we'll finalize the date. Okay, so 20% assignment. So a question will be given and you will answer. So most of the, I think all of the assessment, okay, test 3, test 4, assignment 3, assignment 4, and the final assignment, I think this one we can see assignment 5, all will be conducted via e-learning. Okay, so meaning to say that the test 3 will be an online test, test 4 online test, assignment 3, assignment 4, and this final assessment will be you have to submit online. Okay, I think it will be similar to whatever you have done for your IEK 101. Okay, the concept is going to be is similar, right? You will have a few questions for tests. Some is going to be multiple choice questions, some going to be calculation question, and some is going to be um, definition or more understanding questions, right? So it's combination of both to actually see whether you are able to understand the concept and whether you are able to do the calculation. Okay, so any questions regarding the assessment or anything I've talked about until now? Anybody have any questions? You can unmute your mic or you can uh, put it in the chat box. Either way, it's okay with me. Any questions? Okay, thank you, Siti. So far, no questions. Okay. So I hope you understand. Okay. I hope you understand why I'm telling you all this, because this is very important. Okay. Because I know that you are taking more than not only this subject, you have other subjects, or you might be taking around 20 units this semester, and you have difficult subjects as well. Okay. This is one of the difficult subjects. So I'm telling you this in advance so that at least you can prepare yourself. Okay, so you won't be shocked all of a sudden you are getting so many things to do at the same time. Okay, so if no question, we can move on. Okay, as usual, okay, I just put a screenshot of our front page of our IEK 108 Process Fluid Mechanics e-learning webpage. Okay, so, since we are talking about fluid, so water is, of course, a type of fluid. So that is the inspiration behind the images that we have chosen for this subject. Okay, so from here, just if you have time, you can just go through all the materials that I have put for the two topics that I have mentioned before this. Okay, so most of it will be in the e-learning, and from time to time I will update, and I will also try to upload all the online, like the recorded videos. Okay, so from starting from tomorrow, I will record all the lecture that we have, whether it's 1 hour or 2 hours, whatever it is. So if let's say you have something that during my explanation you missed, or you went to the toilet or anything, right? You lost focus or anything, you will always have the opportunity to rewatch the videos. Okay, so I'll upload everything on the e-learning. Okay. Okay. So before we move on, I have just few more slides to go. Any questions? Everybody clear so far on the topics, on the textbook, on the assessment that we will have for the next 7 weeks? Anybody have any questions? Okay, no questions. Okay, so now you have learned the fundamental of fluid mechanics with Dr. Halina. Okay, I've mentioned in the earlier part of the class, and the second half is going to be more on the application. Now, if you are, the most important thing that you need to ask yourself, or you need to ask me, or you need to ask your friends, or you need to discuss with your friends, is that why we need to learn this subject. Okay, believe me, okay, this is considered as one of the more difficult subject, because it has and it will involve a lot of equations and calculation. Okay, other courses, they might be only, in terms of theory, you have to memorize, you have to understand the concept, you just have to write in terms of essay form. But when we are talking about this kind of engineering courses, definitely it will involve a lot of calculation. Okay, there will always be some, questions to ask about definitions, about explanation, briefly explain, briefly discuss all these things. but most of it will be calculation. So now the question is that why is it important for us to learn? Where will I apply this? Is it that important that I have to, stay up every night, scratch my head, you know, give me headache to learn these things? So the answer for me is yes, it is very important for you to learn, right? You might not use it. Whatever we are learning here, you might not use it straight away. Okay, whatever that Dr. Halina and I've taught you, it's basic, right? It's very specific. All the examples that we are gonna give you, all the explanation is gonna be very specific, right, to the topic. But sometimes you might not use it for now. Okay, you might not use it, whatever you have learned, directly whatever you have learned here. Okay, you might use it indirectly. Okay, so to show you an example of where you might use it directly or indirectly. Okay, so this is actually an example of a wastewater treatment plant. Okay, it's an example of it's an aerial view of wastewater treatment plant. Okay, so you will have a lot of different type of um, system or unit operations, right? You can have like this kind of pond, right? And then you have this kind of facilities, all these things, right? So all these things. So one of the uh, how would I say, the field of work that you might be working on after you have graduated from environment technology, right? We are talking about environment, right? So one of the most important part is that you might be working in a wastewater treatment plant. Okay, in a wastewater treatment plant. So but you might not be, so if you ask me, you might not be okay. If I work in wastewater treatment plant, I will use the fluid mechanics, whatever I've learned directly. No, but sometimes you might use it indirectly. Okay, so for example, if let's say you are working in a wastewater treatment plant, so based on the name also, you must know that the function of a treatment plant is to treat the wastewater. Now, wastewater can be there are a lot of type of wastewater. You can have industrial, you can have domestic. In the industrial, you can have metal based, you can have organic, you can have chemicals, so you can have a lot of different type of wastewater. The goal is that before you release it to environment, you want to treat it. Why? Because if you release it without any treatment, it can cause a severe or adverse effect to the environment, to us, to the animals, to the plants, to everybody, right? We had a disaster, right? If you remember, Kim Kim River in Johor, right? That was release of toxic waste into the environment. So we don't want to do that. So whenever we have wastewater, we have to treat it first. Okay, so you might be working as the process engineer or safety officer or a consultant on how to develop a more efficient way to treat the wastewater in terms of the application and so on and so forth. Or you might even be working for the Department of Environment, DOE of Malaysia, where you have to go and check the sites. Okay, so where does this fluid mechanics come into the play, right? So how does knowing or understanding about the fluid mechanics help you in your future work? Okay, so again, this is an example of a type of wastewater treatment plant. Okay, so if you see here, there are a lot of different kind of type of unit operations, right? You have filter, screen, microfiltration, MF break tank, transport pump station, cartridge filter, RO feed pump, UVF, UVP, flush tank, and so on and so forth, right? To send Santa Ana River or OCDC ocean. So this is like just the final discharge, right? So this is going into your system and this is coming out of the system. Okay. So if you remember what I mentioned just now, our topic is gonna be on the transportation, metering, and the mixing, right? We have transportation and metering of your fluid, and also to understand the mixing process of a liquid. So if you see here, when you are dealing with, let's say this is the starting point, okay? So starting point meaning to say that it will start here, then it will move, you know, whatever the route is, move, and then it will go out. So this is basically the route of transport, okay? So for example, now if let's say you are a safety officer, okay, the function of a safety officer is to make sure that the whole treatment plant, the whole thing is safe, okay, no accident happen. That's why safety is very important, right? That's why you need to know. So for example, now if let's say something happens, let's say here, right, there is an accident here, so you will have to go and, you know, figure out what happened, what went wrong, who is responsible, what happened to all the safety measures that you put, or your company put, or your senior put, to make sure no accident happen. So if let's say you don't understand the system, if you don't know how the fluid is being transported, what the equipment used, and how is the process going on, so how are you going to find the problem? How are you going to find what went wrong? Okay. So in order for you to do your job as a safety officer, so indirectly, you must know the overall process flow. What are the equipments? How is the fluid being transported? Is there any problem with the mixing? If let's say you need to understand how is the mixing happening. If let's say you see here there is a pump station, so is there an error with the pump? What type of pump you're using? What is the power of the pump? Is this pump suitable or not suitable? So all these things you have to take into account if you are a safety officer, or even if you are a process technician or engineer. So if let's say you don't understand the basic, the fundamental of what is happening here, so it will be very difficult for you to actually do your work properly. Okay. So again, here this is a second type of treatment plant that you have, right? So you have raw water tank, gravity filter, filter water tank, antibiotic equipment, all these things. And if you see here, there are a few symbols here, right? So this actually, you can say this is a symbol of pump. This is a symbol of pump. Pump, pump. Okay, pump and also pump. And all this line, right, going in, going out, going up, going down, all these things is actually your piping system. Okay, and when you have your piping system, there must always be something flowing in the pipes, right? So that is why it is very important for you to understand and to know the basic. Okay, I'm not saying that you must be a master, but you must know the basic. Whatever we are teaching you in the class, in this IEK 108, is the basic. It's not the advanced level of fluid mechanics. So whenever you talk to people, whenever you are working or whenever you go for an interview, you have at least know, oh, when we're talking about this is actually a positive displacement pump, or this is a centrifugal pump, or this is your suction lift condition. So whenever I'm talking all about this terminology, now you don't have any idea because you have not learned anything about pump design. But hopefully after the 7 week that we have together, you have at least understand how to actually design pump. Why is it that we have, you know, this is your tank, why is it we have to go here and go up? Why can't I just have my pump go straight like this? Why do I have to go something like this? Why do I have to make this turn? And then why is it going out on top? Why don't I just go like here, right? Because if you see here, the more you go, the more angle you have, the more friction, the more costing, everything is there. So why? So all this thing has a reason for it. Why can't I have my water come out from here and go like this? Okay. So all these things is involved in the fluid mechanics. It's involved in the design of the whole treatment plant or any kind of plant. Okay, so I'm just giving you an example of a wastewater treatment plant because this is the most easiest example I can give related to your environmental environment, right? But whatever we are talking about fluid mechanics, wherever you go, whatever kind of plant or any kind of process unit that you have, when you have fluid, there will always be pipe and pump. Okay, pump is the device where you use to push your fluid, okay, or your liquid. Pipe is the vessel that you pass, you channel your liquid, right? If you have just pump and you don't have any, okay, just let's say we have this pump, okay, but you don't have any piping attached to it, so your fluid just will just pour out. Nothing will happen. It will not go from one point to another point. So here you need to understand pipe and pump. Okay, so in order for you to understand the pump, you have to understand the equation, the fundamental. How does the equation was developed? Okay, so okay, I hope everybody is still with me. So basically, the summary of our class for today. Okay, this is I think my final slide. Okay, this is my final slide. After this, we're gonna end our slide. So the final summary we can say is that whatever you have learned with Dr. Halina is very important. If you don't remember, please take some time, just do some revision. And out of all the things that you have learned with Dr. Halina, everything is important. But the most important and the most frequent equation that we will use is your Bernoulli equation. Okay, so this Bernoulli equation, we have this is specific for pump design because we have already incorporated the pump work. WP here is the pump work term in this Bernoulli equation. PA is the pressure, G is your gravitational acceleration, Z is your distance, A is your coefficient, VA is your average velocity, and then your rho is your density, GC is your conversion, okay, conversion for your gravitational acceleration, HF is your friction factor, okay. HF is your friction in the pipes and so on and so forth. Okay, so finally, everybody must make sure they understand this equation and they remember and know each and every term in this equation. Okay, so before we end our class for today, okay, so I just okay, because if I ask you to put in the chat box or put in the unmute your mic and give me the answer, what do you remember about Bernoulli equation that you have learned with Dr. Halina? None of you will give me any answer, right? So to avoid that, okay, so I'm going to be using this called Mentimeter. Okay, so you can either use this link or you can just go to menti.com and use this code and answer this question. Don't worry, your answer will be anonymous. Okay, it will not say that, oh, Siti answered, you don't know anything at all. Whatever you remember. If you don't remember, then you don't remember, right? Because there's no point lying to me. Okay, at the end of the day, you must know what you know. Okay, it is important. I'm just here to give you information. I'm just here to teach you or to explain to you all this concept. If you don't know, then you don't know. Okay, even if you lie to me, you won't gain anything from it. Okay, so please uh go using this website, this link, or using this website and using this code. I think if you click this one straight away, you can just copy and paste. I think I will also put this link in the chat box. Okay, so it's easier for you to just click it. Okay, so just write whatever you remember about Bernoulli equation. Okay, if you don't remember anything, then just write I don't remember anything. At least you know that you have work to do. At least you know where you start. If you remember anything, just write whatever you remember. Okay, so I'll give you about 1 or 2 minutes. Just write your answers and then we'll see what is the popular answer from everybody. Okay, so please, I hope that you will give me some cooperation and just answer the question as honest as possible. I promise you, it will be anonymous. I will not know if, let's say, whoever it is, let's say Alice said that, I don't remember anything, or maybe Fitri said, or Ashikin said, or I remember something. Okay, it will be anonymous. Okay, so use that link, or you can use this code. Okay, I'll just continue sharing this one. Use this link, or you go to menti.com and use this code to answer the question. Okay, I'll give you around 1 or 2 minutes. Okay, I can see a few answers, so I'm not going to share yet. So please, everybody, only a few people has answered this. Still waiting for the other people to answer. Okay, so I'll just start sharing the answers that everybody has given. Okay, good. Keep on coming. Whatever you say, it's honest, it's good. So at least we know where to start. Okay, what do you remember about the Bernoulli equation? The formula. Okay, you remember the formula. I don't remember. Not really clear with that. Don't remember. Bernoulli equation is used when the flow is steady, incompressible, and along a streamline. It can use to find height, pressure, and velocity. Equation can also be modified to find head loss. Okay, very good. A conservation of energy law for flowing fluid. I don't know about Bernoulli equation. Okay, Bernoulli equation is applying the mechanical energy balance. Okay, from the equation we can know the relationship of density of fluid, pressure of the fluid, velocity, and the height of the fluid. Okay, P1 minus P2 is equal to rho GH. Relationship between pressure, kinetic energy, and gravitational potential energy. When the speed of the fluid increases, the pressure at the interface between the object and the fluid decreases. The Bernoulli equation is a special form of mechanical energy balance. Didn't remember? Head loss, pump work, volumetric flow rate, continuity equation. I still not clear about Moody chart and momentum balance. I hope doctor can teach more details. Sorry and thank you. Okay. I remember Bernoulli equation but not very clear. Okay. And then Bernoulli equation can be derived from the principle of conservation of energy. Static pressure plus dynamic pressure equal to total pressure. A rule of energy conversion for a moving fluid. Okay, the equation no remember. Okay, we have 21 students that have actually answered. Any more? Okay, it's good that at least you know that if you don't know, it's better, right? There's no point saying that something you don't know. It's better that you just say that. So I can say that majority is not very clear about the Bernoulli equation. Okay, some of you are giving very detailed explanation, and some of you, most of it is saying that it's a conservation of energy law. Okay, energy law, and then conservation of energy related to fluid dynamics, mechanical energy balance. So you can see here we have mechanical, but you have conservation of energy. Okay, anybody else? 22 students have answered, right? So at least we know where we are. Okay, if let's say we don't understand, or we don't remember, or we don't know, then we know that we have to work harder, right? Because we want to achieve our objective that we set today's class, right? At the end of the class, everybody must understand and able to apply the Bernoulli equation. Any more? 22 students have answered. Anybody else? We should have around, let me just see the participant, around 40 students. So we are missing around 18 students who are, I don't know, shy, don't want to share their opinions. Okay, so I think we have a clear idea what we need to do. Okay, so as I mentioned, okay, so I'm going to stop sharing the screen. So it's good, right? At least we know where we stand. So at least we know where do we have to work on. So as I mentioned here, Bernoulli equation is a very important equation, especially when we are dealing with our pump design. Okay, whatever we are going to be looking at, whatever we are going to be developing the equation, changing the equation, manipulating the equation, will be coming from this equation. Okay, it's coming from this equation. So there's one term, two terms, three terms, four terms. So 4 plus 4, there are 8 terms together. Okay, so we will try to go slowly, as slow as possible. I'll try to explain each and every term and how they are related to our pump design. Okay, and we will show how do we actually use this in our pump design. Okay, what are the elements and what are the most important thing that you need to do. Okay, your main task is able to apply this equation for pump design and metering. Okay, meter your flow measurement meter. Okay, so thank you very much everybody for those who actually gave your opinion. Let me just check. Yeah, so this is the final people. 22 people answered. I don't know what happened to the other 18 people, but it's okay. So from time to time, maybe I'll use this platform to actually ask whether you understand or not, because if I wait for you to put in the chat box or unmute, I will just be waiting, right? I don't think anybody, I think everybody is shy, right? You don't want to talk to me, or you don't want me to know how you sound like. It's okay. So I think by using this kind of platform, you can actually express yourself, and actually it is good for me to know whether whatever I'm talking is actually being understood by you or not. Okay, so I think it's a good stopping point for today. So tomorrow we'll have class. So tomorrow we'll just go through our first topic, which is going to be on pipe fitting and valve. Okay, and then I will always try to relate back to how is it going to be applied in industry or in whatever field that you are working. Okay, in whatever what to try to show you the relationship between why is it important for us to learn this and how are you going to apply it directly or indirectly. Okay, so I because we don't know which field you are going to be working on. Okay, so but believe me, sooner or later, however it is, even in your house, Okay, even in your house, if let's say you are living in an apartment or condominium, there is still gonna be an application of fluid mechanics. Okay, it's just that whether you are aware or you are unaware. Okay, so for tomorrow's class, we are going to be looking at our first topic is going to be on pipe fitting and valve. I've actually uploaded the updated version of the lecture notes on the e-learning, so you can always download it, have a look at it. So tomorrow we can just have a quick discussion about it. Okay, and I've also uploaded a few videos on piping and valve on the e-learning. Okay, so I think that's all for today. I will stop the class for today. Thank you very much, everybody. So as usual, even though you are in USM, right? So we are having convocation weeks today. So it's going to be a lot of people having coming and going out of USM. So as usual, please stay safe. Please take care, everybody. Take care of yourself, and we'll see you again tomorrow. Okay. Goodbye and assalamualaikum, and have a nice lunch, everybody.